Hey everyone, so this is our Module 4 Team Teach Lesson 4. We're going to continue on probability and we're going to focus on permutations and combinations. I'm Heather.
I'm Tony.
I'm Skylar.
And let's get started.
All right, Heather. With no restrictions, how can two 11-person volleyball teams be formed?
Good question. So first we need to know how many people that we have to form these teams. So we have 6 boys and there's 16 girls. So since there's no restrictions, we can do any combination whatsoever. And so you have a total of 22 people, and you're wanting to make 2 11-person teams. So N equals 22, and R equals 11. I used Excel to do this answer, and so when you put it in, N equals 22 and R equals 11, you get 352,716 possibilities into making the two 11-person volleyball teams. Tony, how many ways to group of 22, including 6 boys and 16 girls, can be formed into two 11-person volleyball teams?
Okay, so this time we're going to do so that each team has 3 of the boys. So now we know that our problem is going to be a combination. So we have our form here, which is going to be C in R equals N exclamation R exclamation. So the team form is still a combo. So N is going to equal 6 and R is going to equal 3 for our 6 boys, and then the 3 for our total of 6 boys, and then our 3 boys that are going to be on each team. So okay, so we're going to put in our 6 for our N and our 3 for our R. And so we have, we're going to do, to get our 6 exclamation, what you would do was you do 6 minus 3 plus 1, which gives you 4. So you would multiply from 6 to 4, which is 6 times 5 times 4. And so you put that over 3. And then next, when you do your 6 times 5 times 4 over 3 exclamation, you'll get 20. So that's our answer for that. And now you have to find the girls so that way you can put the boys and the girls together and get your answer. So you do 11 minus 3, which is the boys, and it gives you 8 girls on each team. So now it's going to be 16 and 8. So 16 is going to be your N and R is going to be your 8. So to do your 16 exclamation, it's going to be 16 minus 8 plus 1, which gives you 9. So you would multiply from 16 to 15 to 14 to so on, all the way down to 9. It's going to be over 8. And then that's going to give you 12,870. And so now you put it together and you get 20 times 12,870, and then you divide that by 2, which gives you 128,700. So that's how many ways to form teams with 6 boys per team, with 3 boys per team on each team. Okay, so Skylar, how many ways can a team be made if all the boys are on one team?
So if all the boys are on one team, you have 16. You have to find out how many girls you're gonna have. So on my Excel sheet, you have the 16 girls, and then you have that there are only 5 left that can be put on a team after the 6 boys are already on the team. And so there are 4,368 combinations for that, and you need one more team of 11, which would be just strictly girls. And then so there you would multiply the number of ways the boys can be arranged by the number of ways the girls can be arranged, which is still 4,368, but you need 2 teams, so you would divide that by 2. So there are 218 ways a team can be formed if if all the boys are on one team. So Heather, what is just kidding. how do you find the probability that both cards are red when you're drawing from a deck of 52 cards?
Okay, so I will be showing this one. Okay, so find the probability that both cards are red. So we know that half a deck of cards are red and the other half is black. So since so we know that there's 52 cards, so you divide that by 2. So there's 26 red cards in our deck of cards. So we also know that since the order of the cards does not matter, drawing 2 cards is a combination. So we have our 26 red cards, and so since we're trying to find what the probability of drawing of 2 would be, we do 26 exclamation over 2, and then you do 26 minus 2 plus 1, which gives you 25. And so it's going to be 26 times 25 divided by 2 exclamation. And so that's going to be 325. And so now you have to find the probability of all the cards. So it's going to be 52 over 2. And then you do the 52 minus 2 plus 1, because you have to do your n minus your r, and then you add 1. So that gives you 51. So you do 52 times 51 divided by 2, which is 1,326. And then you have to put your red cards over your full deck of cards, which is 25 over 102, which is the probability of both cards being red. All right, Heather, what is the probability that the 2 cards drawn from 52 cards will not be a pair?
Okay, so since you did it where there's 2 red ones, so we know that our total for the deck of 52 is 1,326. And so we're trying to get to where it's not a pair. So we have C42 because there's 4 different suits and we're only drawing 2 cards. And we know that each suit has 13 cards. So what we'll do is we'll put the total for the deck of cards minus the 13 and multiply that by the 4 factorial over 2 factorial. And we get 1,248. So then you would take the 1,248 and divide it by the total of the deck, which is again 1,326, and you get 16 over 17 is your probability for it not being a pair when you pick 2 cards. So Skylar, what is the probability that the 2 cards drawn from the deck will not be a pair?
So just like Heather just said, out of the 52 cards, 26 of those cards are red because you have the 4 different suits and 2 suits have the same color. So from what Tony told us, there are 1,326 possibility of drawing like 2 cards, and then you have the possibility of the 2 cards that are not matching. So the answer for that would be 1,248. And so there's a 94% probability that
I'm sorry.
that's so okay. Okay, now Heather, because that's right now. There are 4 boys and 3 girls on the debate team. How can you line them up where no 2 boys are side by side?
Okay, so as you can see here, I have them lined up, boy, girl, boy, girl, boy, girl, so on. So the 2 boys aren't there, but how do you figure out, like, mathematically? We're going to use permutation. And so that equation is actually looks like this. You're just going to have P, N, and N. So the numbers are going to be the same, and so it'll be N factorial. So what I did here is just did the girls. And so we have 3 girls, so our equation is going to look like this. So P33 equals 3 factorial, which equals 6. But Tony, can you help us out and further it with the boys and the girls together?
Yes. Okay, so there are 4 boys and 3 girls. So what you do is you add your 4 and your 3 to get your n, which will be 7. And so your problem, it's going to be a permutation. So pretty much your problem is n and n. So you do 7, and it'll be 7 exclamation, which is 5,040. So we know The number of different ways to line the girls up is 6 ways, and the boys can be lined up in 24 different ways. So we multiply the number of different lineups together and divide by the product of integers from 1 to 7, which we get 24 times 6 over 7, which is 0.0286, which is the probability that no two boys are side by side. Oh, where are we at? Okay. There we go. Okay, Skylar. 4 boys, 3 girls. How can they be lined up where no two boys are side by side?
Okay, so just like Tony said in her presentation part, you have the permutations, and then so you have 7 is total, so 7 factorial, and then you have the 4 boys, which is 24 different ways you can align them, and then you have the 3 girls, and there's 6 different ways that you can align them. So after you align them each different way, however many times you're going to do it, the probability that they're going to line up not side by side is, I rounded mine because that's a long number. It's 0.03%.
Skylar, how many balls are in the urn?
So there are 14 balls in total, and you're wanting to pick 2 of them. So you would have 14 factorial over 2 factorial times 12 factorial. Because this is a combination, it doesn't matter how they come out or how they're in there. So you have 91 total options to choose from. Tony. 2 balls are drawn at random from the urn containing 4 white and 10 red balls. Use the equation for CR to compute the probability that both balls are white.
Okay, so we know that we have, there's going to be 4 white balls and 2 balls that are going to be drawn. So N is our 4 white, and then R is our 2 balls that are drawn. So it's going to be 4 over 2, which gives you, and then you go 4 minus 2 plus 1 because you subtract your R from your N, and then you add 1, which gives you 3. And so you've got 4 times 3 over 2, which gives you 6. And that is, and then it's a 6 over 91, which equals 0.07 is the probability that both balls are white. Okay, Heather, 2 balls are drawn from the urn. What is the probability that both balls are red?
Okay, so we have 10 red balls and we're just trying to draw 2 out of it. So once we put them in the equation, we have 45. Well, since we know that we have 91 ways to draw 2 balls, we would take the 45 and divide it by 91, and we would get 0.49. So almost 50% of the time you will draw 2 balls, it'll be red, strictly because there's more red balls in the urn than there are white balls. So you're looking at about 49% of the time is your probability for drawing 2 red balls.
Heather, how many different signals can be sent up on a flagpole if each signal requires 10 blue and 10 yellow flags?
Okay, so here we have 10 blue and 10 yellow flags. We've got to use both of them. So we have 20 flags, and we are looking to see how many signals that we can put up the flagpole. And when you put them in Excel, again, you have N equals 20, R equals 10, and it automatically puts it into the equation for you. And so the number comes out with 184,756 possible signals that you can send up with the flags. Tony, can you show how many different signals can be sent up on the flagpole if each signal requires 10 blue and 10 yellow flags?
Yes. Okay, so we know there are a total of 20 flags. So, but there's Ooh,
Y'all, I'm sorry.
it's okay. So we know there's a total of 20 flags, and there's 10 blue and 10 yellow. So we're going to use 10 as our R and 20 as our N. So we do our R minus our N, which is 20 minus 10 plus 1, which gives us 11. So in our equation, we're going to do 20 times 19 times 18 all the way down to multiplied to 11 over 10, which is going to give us 184,756, which that is how many different signals that can be sent up on a flagpole. All right. Skylar says SOS.
Okay, so there are 20 different flags that are needed for however many signals we're going to do. It's asking how many different ones can be made. I also made mine in Excel. So as Tony said, your N is going to be 20 and your R is going to be 10. And so after you use the formula to find how many different possibilities that you could use, there are 184,756 possibilities that we could do using 20 different flags. Tony, can you show all the arrangements of the letter in Arkansas?
Yes, I can. Okay, so there are a total of 8 letters in Arkansas, but there are only 5 different letters. So N is going to be 8, and we are going to find how many different times each letter is done. So in Arkansas, there are 3 A's, there's 1 R, there's 1 K, 1 N, and there's 2 S's. So what you do is you put it in this formula. You put your N here, and then you put your R's, which is, you know, your different, how many different times each letter is done. So you would have, you'd have 3 times 1 times 1 times 1 times 2. And when you put that in your equation, you get 3,360. So there are, oh, so there, so there are 3,360 possible arrangements of the letters in the word Arkansas.
Y'all on my screen, y'all know what I'm doing that.
Okay, so Heather, how can you arrange all the letters in Arkansas?
Okay, so just like Tony was saying, you have to first figure out how many letters are used in the word. So you have 3 A's, 1 R, 1 K, 1 N, and S has 2. Once you figure out those 5 letters, you can use this following equation to figure out the possibilities of how many arrangements you can make. We know that there are 8 letters in total, so N is going to equal 8. And your equation is going to look like this, 8 factorial over all your letters. And so once you put that into the calculator, you're going to get 3,360 possible arrangements for the letters in Arkansas. And Skylar, can you go over how to get the arrangements for Arkansas?
Well, just like all of you nice people just said before me, you have to find how many different letters are in the word Arkansas. So there's 3 A's, 1 R, so on and so forth. You guys have already been told this. So after you put it into the formula, you have 8 factorial over 3 factorial times 1 factorial times 1 factorial times 1 factorial times 2 factorial. And altogether, that equals 3,360 different ways that you can arrange the letters to make the word Arkansas. Thank you guys so much for watching. This is our last video, so that's exciting.
Hi.
Bye.
Bye.
It's not working.